Hello everyone, welcome to Science and Technology Part 1, Standard 9. In last lecture, we studied about numericals from this chapter. Now, this is our lecture number 11. Today, we are going to learn Newton's laws of motion. See the picture in which some objects are shown. In left corner, ball is at rest position on the ground. In the second picture, book is kept on table. In the third picture, a person is shaking a tree of branch. After that, fruits are falling down. In the last picture, the blades of fan are rotating. This picture shows that objects have some inertia. We have learned that inertia is related to the mass of the object. Newton's first law of motion very, describe this very properly and is therefore also called as law of inertia. Newton's first law of motion is also called as law of inertia because, as we know, if the mass of the table is greater than that of mass of book, then inertia of the table is also greater than the inertia of the book, and that is why the first Newton's first law of motion is also called as law of inertia. Let us see Newton's first law of motion. You may have done this activity. Fill a glass with water or sand, keep a piece of cardboard on it, keep 5 rupee coin on the cardboard. Now strike the cardboard using your fingers. What will happen? The coin has inertia due to its particular mass. That is why it tries to remain in the state of rest. After striking the cardboard with your fingers, the cardboard will thrown off and the coin will fall down in the glass because of the inertia. We see that the coin has inertia due to its particular mass, and that's why it tries to remain in the state of rest, and that's why coin fall down in the glass and the cardboard is thrown off away. Let us see the another activity. You must have played tug of war. So long as the forces applied by both the sides are equal, that means the balanced, the center of the rope is static in spite of the applied forces. In this picture, the force applied by right side is greater than that of force applied from the left side. Here we can see that the force on both the sides applied is same. The force applied from both the sides is same, that is balanced force is applied on that rope, and therefore the rope remains as it is, as both the sides having same force. A net force gets applied in the direction of the greater force, then that will be unbalanced force. In this picture, the force applied from both the sides is same, therefore this is FA is equal to FB, that is both the surface forces are balanced. But as you see in this picture, the force applied from left side is greater, that is FA is greater than FB, therefore the rope, that red point, is attracted towards left side. Red point is on the left side. That means in this example we see the balanced and unbalanced forces. If the forces applied are same or balanced, then the rope will remain as it is. On the other hand, when the applied forces become unequal or unbalanced, a net force gets applied in the direction of the greater force and the center of the rope shifts in that direction. In this picture, the center of the rope, that is that red point, gets shifted towards the greater force, that is on the left hand side. This is the activity which gives the example of first law of motion, balanced force and unbalanced force. An object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. This is the Newton's first law of motion. Again see balance and unbalanced force. When an object is at rest or in uniform motion along a straight line, it does not mean that no force is acting on it. When the book is kept on table, the force is applied by table as well as by book. The force applied by book is on table and the force applied by table is on book. And that's why it gets balanced. If there is the uniform motion, again there are the forces which are applying on the object. See here, balanced force and unbalanced forces. The book is kept on the table which is at rest position because force applied by the table on the book is F2 and force applied by the book on the table is F1 and they gets balanced. The force applied by book on table is less as the mass of the book is less, but the force applied by the table is greater and the book gets balanced by the table. In this example, the car is in uniform motion. At that same time, the mechanical force and frictional force are acting on it and which are gets balanced, which are acting in the opposite direction and therefore they gets balanced. Newton's first law of motion explains the phenomena of inertia, means the inability of an object to change its state of motion on its own. Newton's first law of motion also explains the unbalanced forces which cause a change in the state of an object at rest or in uniform motion. Newton's first law of motion also explains the unbalanced forces which cause a change in the state of object at rest or in uniform motion. We see the uniform motion of a car. This is the another example, cup and saucer. External force is applied and that cup is balanced from the table, kitchen table. Observe this picture. An object at rest remains at rest and an object in motion remains in motion with the same speed and direction. What this picture shows? First, I will show you my idea that an object in rest will stay in rest. So I will place a saucer ball on this brick wall and we will see what happens. With a gentle push, the ball starts rolling along the wall. And here, so as you can see, the saucer ball stays at rest and does not move because there is no unbalanced force acting upon it. Next, we will try pushing a saucer ball down this wall and see what happens. When a gentle push, with a gentle push, The ball starts rolling along the wall. This is the Newton's first law of motion. Again, you can see the another example which is applied to aeroplane. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. When flying at a constant altitude, if thrust and drag are equal, which are shown in the figure, if thrust and drag are equal, aircraft holds constant airspeed. If thrust is increased, aircraft accelerates, airspeed increases. Drag depends on airspeed, then drag increases. When drag is again equal to thrust, aircraft no longer accelerates but holds a new higher constant airspeed. That means first Newton's first law is applied in airplanes.